Bismillahirrahmanirrahim. Assalamu alaikum. This is Jahangir Sumro, Assistant Professor, Electrical Engineering Department, Sakkar IB University. As we know that we are continuing the course of LabVIEW Core 1, we have completed 6 lessons. Now we are starting the recording of lesson 7. The lesson 7 topic name is Modularity. In this lesson, you will learn to recognize the benefits of reusing code and will be able to create a subVI with a properly configured connector pane, meaningful icon, documentation, and error handling. The topics covered will be understanding modularity, icon, connector pane, documentation using subVIs. In this lesson, we will also cover exercise 7.1 temperature warning VI is a subVI. Alright. So what we will start we will start our discussion with understanding modularity. So objective is to recognize the benefit of using modular code and identify sections of code that could be reused. Alright, so we'll understand modularity and subVIs. Let us start with what is modularity. The degree to which a program is composed of discrete modules such that a change to one module has minimal impact on other modules. This is called modularity. So modules in LabVIEW are called subVIs. So what is a subVI? Simply a subVI, a VI used with another VI is called a subVI. So basically, LabVIEW uses subVIs to create modularity, and subVIs are similar to subroutines or functions in text-based programming. Alright. So subVIs are basically repeated code, and repeated code can become a subVI. Use subVIs when you have a code that performs identical operations on different parts of your block diagram or in another VI. Say suppose here you see this operation is performed on two places. So this is a basically repeated code, and this can become a subVI. So you can convert this portion of the code into subVI, and see here it is converted into the subVI. So this is a concept of subVI. Alright. You see this following pseudocode and block diagrams demonstrate the analogy between subVI and subroutines. As already discussed, that basically subVIs are similar to subroutine in text-based programming languages. So you see here in this code, average of two numbers is performed. Alright. And you see here that average function code is called in VI, called in main function calling program code, and average is performed on two numbers, and its output is shown as point average. Same thing is happening in LabVIEW. You see this is a subVI block diagram. This is the icon. Icon is a graphical representation of subVI. And you see this is a calling VI block diagram, is similar to that in text-based language. So you have called this subVI and you are performing average on 2 points, point 1 and point 2, and this is the point average. Alright. So what is icon? So when you talk about subVI, icon is a main concept. So the objective is to recognize characteristics of a good icon and use the LabVIEW icon editor to create a custom icon. In this, we will discuss characteristics of good icon and using the icon editor. Alright. So what is icon basically? A VI icon is a graphical representation of VI. It can contain text, images, or a combination of both. If you use a VI as a subVI, the icon identifies the subVI on the block diagram of the VI. And what is the purpose of icon? Is discussed that purpose of icon is that the icon displayed in the upper right corner of the front panel is the same as the icon that appears when you place a VI on the block diagram. So if this is a icon you see on the front panel, when you place this sub-VI into the main VI, the same icon will appear when you place this sub-VI on the block diagram as you see over here. So this is the purpose of icon. What is characteristics of a good icon? A good icon conveys the functionality of the VI by using relevant graphics and text. You can also use banners to identify related VIs. So simply, a good icon conveys the functionality of the VI using relevant graphics and descriptive text. So how to create icons? You use icon editor for this purpose. Use the icon editor dialog box to edit a VI icon. You can customize your icon with text, graphics from the glyphs library and banners. Additionally, you can create and save custom templates. Demonstration. Now, how to create an icon? I will demonstrate this by using LabVIEW. For this purpose, let me create a new VI. Say suppose I'm using Express simulated signal here of 50 Hz, 50.1 Hz. Alright. Similarly, I need another signal as well. There should be a shape of square, and I need, say suppose, another signal of shape of triangle. Alright, so let us take merge signals from signal manipulation. Let us merge these three signals together. Alright, okay, and then let's take waveform graph to see the three signals on waveform graph. Let's run it. You see, you are observing sine, square and triangle signals on this waveform graph. So this is basically a triangle shape. This is basically square, and this is basically sine. Let's see all these together. Alright, now you see this is the icon, and now we are discussing how can we create an icon. Now this is a default icon of LabVIEW, and here you see that this default icon does not convey meaningful information. So how can you edit it? Right click and go to edit icon. Alright. So let us remove the default icon. Now you can also write text. Now say suppose what is happening in this subVI, this is basically generating three different signals. So I can name it, I can name mixed signal generator here. Now this icon is better than the previous default icon, and this somewhat gives better information about the about this about this VI. And when we'll use this VI as a VI, so this icon can give convey a good meaningful information. But still, everyone in the world cannot understand English, so it is sometimes considered to be better approach to give signal shapes, to give pictures rather than language, rather than text. So sometimes instead of text, pictures and glyphs are encouraged. So I go to the waves and I pick a mixed signal. You see, this is symbol of mixed signal. So I pick up this icon. So finally, now you see this icon conveys better information, and somehow you follow the characteristics of a good icon. All right. All right. So now the objective is to select and configure a connector pane for a subVI. We'll discuss patterns and standards. All right. So what is basically a connector pane? Connector pane is basically a set of terminals that correspond to the controls and indicators of that VI, similar to the parameter list of a function call in text-based programming languages. The connector pane defines the inputs and outputs you can wire to the VI, so you can use it as a sub-VI. Alright. So you see, now you see this is the connector pane that corresponds to the controls and indicators of that VI. Alright. Now what are patterns? A connector pane receives data at its input terminals and passes the data to the block diagram code through the front panel controls and receives the results at its output terminals from the front panel indicators. The connector pane is displayed next to the icon on the front panel window. You see? This is the icon, this is the connector pane next to the icon on the front panel window. You can select from many different patterns depending on how many inputs and outputs are required. So the default pattern is 4:2:2:4. You see, this is a default pattern of LabVIEW. You can change this pattern depending on how many inputs and outputs are required. These are different patterns available for the connector pane. Alright. So assigning terminals. Click the connector pane terminal and then click the front panel control or indicator to assign the terminals. You see in this example, current temperature, maximum temperature, minimum temperature are assigned inputs as inputs to this connector pane, and warning, warning text and error out are assigned as an output. to this connector pin. Let me demonstrate this quickly. So you see, here from I can assign this current input as input. Also this maximum temperature is an input to this connector pin. Also this minimum temperature. Also this error input. This is how, and also output to this these three indicators. And this error out. This is how you assign terminals to the connector pin in LabVIEW. Alright. This is a standard connector pin shown in the figure, which is 4 by 2 by 2 by 4. So whenever you are assigning the connector pin terminals, the reference should be on the top. You see here? Reference on the top, and error clusters should be on the bottom. You see this error input, this is error output on bottom. Inputs should be on the left, as you see here. Outputs on the right, as you see here. Unused terminals can be assigned later if you modify the VI. Alright. Now the objective is to explain how to document code in LabVIEW using descriptions and tip steps, and describe 4 methods for documenting code on the block diagram. So we will discuss VI description and tip steps and labels. Okay, creating description and tip steps. Create descriptions and tip steps for front panel objects in the properties dialog box for the object. In the properties dialog box for the object. Create description for the VI on the documentation page or the VI in properties dialog box. So you see here, in this case, in this picture, this is description of the numeric control maximum temperature. In description, it is written that enter the maximum allowable temperature for your application. So this is tip strip of that numeric control. Enter the maximum temperature. Now it must be noted that this description appears in the context help window, and this tip strip display when the cursor is over an object while the VI runs. Let me show you this quickly. Let's suppose I go to this maximum temperature. I write this in description. Enter the maximum allowable temperature for your application. Enter the maximum allowable temperature for your application. In tip strip, I'm writing enter the maximum temperature. Alright. So when I run it and I turn on the help window, so you see here, when I run it, so tip strip is appear enter the maximum, you see description is appear enter the maximum temperature allowable temperature for your application. So this is appearing in the context help window. Alright. Okay. Next thing, that how can you document basically a VI. Say suppose here in this case, you see this is a sub VI. This is a sub VI. I open this sub VI and I go to file and VI properties. I go to its documentation, and you see this is what written in the documentation of the sub VI. Okay, click OK, click save, and this is main VI in which this sub VI is used. When context help is on, whatever you wrote in that documentation of that sub VI in the VI properties documentation dialog box, the same thing will appear in this context help window. So why do we use it? This is helpful. If suppose you are opening main VI after many months and you do not remember why you created this sub VI, then it is better to document this sub VI so that in future reference you remember that why did I create this sub VI. Documentation will help you in future and will also help other users. If someone opens your code, if the documentation is available in the subVI, and if suppose someone wants to understand that the purpose of the subVI, that documentation will help the new user. So this is the beauty of documentation. I hope now the point is clear. Okay. Further to add the beauty, you can also document the block diagram code. A good review user properly utilizes documentation so that if someone else opens the code, then the other user can easily understand the block diagram code as well as overall the purpose of the VI. So when it comes to documenting block diagram code, one is a free label, alright, another is the own label. Use comments to document algorithm and add reference information. Label structures to specify the main functionality. Label long wires to identify their use contents. Label constant to specify nature of the constant. It is not always necessary to show labels on the function and subVI if they make the block diagram culture. A developer can find information about a function or subVI by using context help window. So how do you create this free label and own labels? Let's have a look on this. Say suppose this is a VI. Now I can right click anywhere and write the free label. Say suppose what is the purpose of this VI? This VI gets the current temperature value and displays on oscilloscope. Simple. Now this free label can help to understand new user what is the purpose of this VI. Alright. And how can you label the wires? So suppose this is a wire. If you want to label it, you can go to visible item and label it. Say suppose wait 1 second because 1000 millisecond is equal to 1 second. Wait 1 second. So this is how you can label the wires. Alright. Okay. Now we will discuss using subVIs. The objective is to demonstrate how to place subVIs on the block diagram, explain terminal settings and error handling, and create subVIs from a section of existing code. We will discuss placing subVI on the block diagram, terminal setting, handling errors, creating from a section of block diagram code. So you can place a subVI on the block diagram in one of the following ways. Either you can click a select VI on the function palette, like you go to the function palette, you see here, you select a VI and place a subVI in the main VI. This is one method. You see, this is the one method. Right click, go to the function palette, click select VI and select the subVI that you want to place in the main VI. This is how you can place the subVI on the block diagram. One way is this. Other way is drag the VI. You see, you can open the Project Explorer, drag the VI from the Project Explorer window to the block diagram. This is the second way. The third possible way is You have opened the front panel, drag the icon from an OpenVI. Drag this icon to the block diagram. This is the third way. The fourth is use the quick drop to search for the VI by name and place it in the block diagram. These are different four ways to place the subVI on the block diagram. Okay, terminal settings. You can designate which inputs and outputs are required, recommended and optional to prevent users from forgetting to wire subVI terminals. LabVIEW sets inputs and outputs of VIs you create to recommend by default. Set a terminal to required only if the VI must have the input to run properly. So in the context help window, terminal labels appear differently depending on their settings. So bold means required. The block diagram containing the subVI will be broken if you do not wire the required inputs. And plain and dimmed. Plain is recommended terminal and dimmed is the optional terminal. The block diagram containing a subVI can execute if you do not wire the recommended or optional terminals. If you do not wire the terminal, the VI does not generate any warnings. But if subVI has terminals which are bold, required terminals, they must be mentioned. So if you do not wire the required inputs, then in that case it will show broken VI. Handling errors, use a case structure to handle errors passed into the subVI. Avoid using LabVIEW error handler VI inside the subVI as shown here. Avoid this practice. And you can convert a section of a VI to a subVI. How? Select your section of the block diagram to reuse, to convert, and then select edit in LabVIEW and create a subVI. Go to edit and then create a subVI option is available in this when you will select the portion of the code. Alright. Okay. Double click the icon to open the subVI and edit the icon and connect a pane. So after creating the subVI, you can double click it to open the subVI and edit the icon and connect a pane as per your requirement and application. Alright. In next part, we will discuss exercise 7.1. Thank you very much.